Good morning. Welcome to Prerequisites of Measure Theory. This is a course important in master degree and doctoral students. First, I will discuss about the historical view of measure theory. In 1902, French mathematician Henri Lebesgue introduced the measure theory in his PhD thesis. His title is Integrale Longerer Air, whose generalization of the Riemann integral revolutionized the field of integration. Then, this was developed in abstract spaces by many scientists, namely E. Borel, Kolmogorov, C. Katodexi, J. Royden, and D. Solomon in the past 2 centuries, that is 19th and 20th century. He is a man is behind the measure theory, that is Henri Lebesgue. The motivation for measure theory is not the Riemann integral is incomplete in any sense. It is a generalization of the concept of integration. In mathematics, getting rid of metric, that is the notion of distance, is one way of generalization. Analysis on metric spaces is generalized to topology. In this way, Riemannian geometry is generalized to differential geometry. Loosely speaking, a similar generalization lies between Riemann integral and measure theory. There are two ways of doing it. Divide the interval a comma b into smaller intervals and sum up the areas of resulting rectangles. This is Riemann integral. Divide the set of values of f, that is a set f of closed interval a comma b, into smaller subsets. F inverse of each of these subsets are subsets of the closed interval a comma b. If we define lengths for subsets of closed interval a comma b, we can compute the integral by summing the lengths multiplied by the corresponding function value. This is Lebesgue integral. Measure theory is better suited for probability theory because we can define a measure on any space. For most practical purposes, Riemann integral is sufficient, but conceptual development is often valued more than practical applications in mathematics. Intuitive explanation of measure theory. Measure theory is the extension of the notion of length, area, volume, probability so that it is countably additive, meaning that if you have an infinite list of separate regions with a size that shrink to a zero appropriately fast as you go along the list, the size of all the pieces adds up in a infinite series to the size of the whole thing. This is the defining property of Lebesgue measure, that is countable additivity. The basic idea. The basic idea is to assign to a real valued function on a given domain a number that gives a reasonable meaning to the notion of area under the graph. For example, the characteristic function, that is we define chi of a of x is equal to 1 if x belongs to a and 0 if x does not belong to a. Of a subset of the domain, one would want to assign the length or area or volume of that subset. To carry this out, one needs to sensible notion of measuring the size of the subsets of a given domain. Formally, this can take the form of a function which assigns a non-negative real number, possibly also infinity, to each subset of our domain. This function should have the property that the measure of a disjoint union of subsets is the sum of the measures of the individual subsets. What are the strategic moves? Measure theory provides the foundation of probability. Measures are important not only because of their intrinsic, geometric, and probabilistic significance, but because they allow us to define an integrals. Theory of measures first and then definite integrals. The more concrete and natural approach. In this, we need some of the prerequisites for studying measure theory. Everyone already known the concept of basic concepts of sets, basic set operation, function and sequences, bounded, derived, open and closed sets on the real line, countability of sets. First, we will discuss one by one, that is basic concepts of sets. What is the first? Set is a well-defined collection of objects. And also you know that set can be represented in a capital letters and elements can be usually represented by small English alphabets, A, B, C, etc. And the examples you already know many things, set of all real numbers, set of all natural numbers are all the infinite and finite sets are there. Sets of a sets and subset, these are the concept. You know that if a bigger set, if you take a capital X is equal to 1 to 6, in that if you choose some of the elements, make a subset that is A is equal to 1, 2, 3, then definitely A is a subset of B. Every element of A is contained in X. Then we say that it is a subset. And also you define a superset. Superset and also equality of two sets. You know that equality of two sets means you know that A and B are equal, then both the elements of A and B having all the elements of A and elements of a set A and elements of a set B are equal number of elements as well as same. And also cardinality also we can define on a set. The cardinality means number of elements present in the set is known as the cardinality of the set. The proper and improper subset. I already mentioned if capital X having a 6 elements and A having a suppose 3 elements, we say that if it is less than the elements of capital X, then we say that if we say that X A is a subset of X, means we say that it is a proper and improper means proper subset means definitely all the elements at least one element less than the set. Improper element means it is strictly contained and also equality. Then there are two types of improper sets, that is one is empty set and whole set is known as the improper subsets. And finite and infinite sets, you already know the things, that is finite number of elements present in the set, we say that it is finite. Number of elements is infinite, then we say that it is an infinite set. Then power set. What is power set? If the power set can be defined, what is that power set? That is 2 power A. that is 2 power n, or sometimes 2 power a or 2 power n. N is the number of elements present in the set. Means, suppose capital X having 1, 2, 3 elements, then its power set containing 2 power 3, that is 2 power 3 means 8. 8 means you know that first empty set will be there. Power set containing all the element proper, improper, all the sets will be there. Then we have 2 power 3, that is 8 number of sets will be there in the power set. Null set means null set or empty set. There is no element present in the set. We say that it is a null set. Singleton set, a set containing single element, then we say that it is a singleton set. Universal set means whole thing that is different depending on the situation, we can define as a universal set. Indexed set means it is denoted by delta. Every element is there is some index will be present, then we say that it is an indexed set. And hereditary property, it is hereditary from all the properties are contained that one, then we say that it is an hereditary property. And pairwise disjoint means A and B are two sets, then intersection, that is A intersection B must be empty. And some of the basic set operations, you know that arithmetic operations, operations related, that union, intersection, disjoint sets, difference of sets, complement of a set, symmetric difference of sets, distributive law, De Morgan's law, ordered pair, equality of ordered pairs, and product of sets in general sense. These are some of the basic set operations you already know. What is the meaning of arithmetic operation? Arithmetic operation means addition, multiplication, division, etc. is known as basic arithmetic operations. You know that union and intersection means here let A be a set and B is another set. Then A union B means a set, both set of all x such that x belongs to A and or x also belongs to B. Any one of them, R will be their union, and x belongs to A and x belongs to B. Set of all x such that x belongs to A and x belongs to B means that is x A intersection B. And also you know that complement means here we say that set A and set B will be there. Here we say that complement means you can see this is the universal set here A and this is A other than A, means x minus A is known as the complement of A. I already mentioned the proper subset of A. B is contained in A. B is the proper subset less than the whole set. And this is the A intersection B. It is A union of B. And symmetric difference, you know that A minus B union of B minus A. That is usually we can represent it in a delta. That is A delta B is equal to A minus B union B minus A is called the symmetric of difference of sets. Distributive laws. There are two types of distributive laws and under the union and intersection. A union of B intersection C can be written as A union B intersection A union C. See, exactly similar way we can make the other one in the distributive laws. De Morgan's law means that is the union of all n running from 1 to infinity complement. If you make a complement, then you get union become intersection, intersection become union. These are the things you already aware of that, and also ordered pair. Usually we can make any Cartesian product of two sets in the multiple cross product or Cartesian product of two sets, that is A cross B is equal to set of all A comma B that can be represented in an ordered pair. Small a belongs to capital A belongs to capital E, small a belongs to capital A, small b belongs to capital B. Then we say that it is an ordered pair. And also we can make a equality of ordered pair means ordered pair A comma B is equal to C comma D means the corresponding elements must be equal. Then we say that it is an ordered pair. And product sets in a general sense means I already mentioned A cross B is equal to set of all A comma B ordered pair such that A belongs to A and B belongs to B. Then we can extend that in A cross, B cross, C cross, etc. Like cross Z means we can make because Z means we have a in alphabet 26 elements we can make that is A, B, C, D, etc. small set such that A belongs to A, B belongs to B. Similarly, Z in general sense can also be extended. Usually that can be extended to N. If it is A1, A2, etc. An such that N dimension, N ordered pairs. That is in the terms of order, it will be in the N time. These are the simple basic set operations you must remember. Then we will deal with one more important concept that is functions and sequences. In that we discuss function, different types of function, on, and into function, real valued map, set function, real valued set function, extended real valued set function, sequence in the sequence, convergent, divergent, and bounded sequence, monotonicity that is increasing and decreasing, and metric space, and some axiom of choice. Somewhere we will utilize the definition of axiom of choice. And on the real line, in another topic that is real line, general real line, and open and closed interval, open set and closed set, continuity, bounded linear set, limit point and derived set, condensation point, cardinal numbers, sum and product, countability of sets, denumerables. These are the basic things to remember. Then only we can start with the measure theory course. These are some of the prerequisite things we must remember, and these are some of the textbook and reference books for learning measure theory. This is the fundamental thing you must we will deal with RHL Royden book we utilize for studying measure theory, that is real analysis, Macmillan 1963, and these three are the reference books. P.R. Halmos Measure Theory, East West Press 1962, and Walter Rudin book is useful sometime, and these are some Indian author books are well written by I.K. Rana, An Introduction to Measure Theory and Integration. I.K. Rana is a IIT professor. He done in NPTEL course, there is an introduction to the measure and theory NPTEL course. Some of you are interested, you can visit that site also. And KP Gupta Measure Theory, there is a Krishna Prakashan Media publication, Mirror. These are some of the references we are utilized for our studying measure theory.